The next talk is fast and resource efficient on-device natural language search for fitness trackers data. And Reza Rawassizadeh from Boston University will be presenting the paper.
Maybe I can go with this one, huh? Yes.
There you go.
So thank you for the introduction. My name is Reza Rawassizadeh. I did this work with a very great students of mine who was a master's student. And we designed a resource efficient and fast on-device natural language search for fitness tracker data. So at the early ages, probably some of you are very young that you cannot recognize when the fitness trackers came. Like 10, 12 years ago, Fitbit introduced, and people think that there's going to be a revolution in healthcare, and I was very happy that I'm going to reduce some weight, but unfortunately, up until now, I was not successful, and even the chronic disease are rapidly on the rise all around the world, especially United States. Chronic disease that are like coming usually from sedentary behaviors have a direct correlations with low-income households. And also on the other hand, even the, I'm okay. Do I need to? I'm okay with this one. No, it's okay. It's okay. Even in the very advanced, highly educated societies, close to 40% of the individuals have difficulties reading graphs. So I try not to put the pictures of those fitness trackers, existing fitness trackers, but you can see that they're all somehow using a graph. Although they're the same, they're using a source of pie chart, but a large group of users still have these difficulties. One of the statistics I recall, although the paper is not very new, it was like 40-something% in Germany. So one reason, one solution to that issue is to use a conversational agents to facilitate sorts of interactions with the softwares and using a natural language query to asking about the fitness trackers data or health-related questions to the device. But on the other hand, they're connecting to the cloud, so all these kind of large language models that are very promising in terms of parsing the natural language questions connected to the clouds and hand over the data to the clouds, which are not very convenient, especially when we are dealing with highly personal sensitive data like fitness tracker data. And they do not provide, up until now, any sorts of natural language interfaces to ask questions, and the storages are limited. So I checked yesterday to be sure what I say is valid, that Google Fit stored the data for 1 year and not for more than 1 year. So I cannot say that, I cannot ask my device whether 5 years ago I'm active or recently I'm active. What is the differences in patterns? So we developed a conversational agents that operates on device, independent from the cloud, and enables the query to, users to query their fitness trackers data while the data is stored completely locally. How do we do that? We employ Bloom filter with the combinations of Huffman coding. And as a result, we are able to store a large amount of data on the smartwatch, and smartphone does not have a problem with storages, but even we are able to query 3 years of data fairly close to the real times on the smartwatch. I'm teaching software engineering. I know it is one of the most boring concepts to talk about the software architecture. So very briefly, I try to jump from it. We do 2 steps. One is pre-processing. The other one is query executions. In the pre-processing, PHR state here as a personal health records, like the fitness data, heart rate data, etc. We give them to the Bloom filter and store them in a temporal pattern. So Bloom filter is a very, very nice data structures, which is very good for facilitating the search and information retrieval. So you have a large amount of data in different chunks, and you would like to see whether a particular data object existed there or not. We can use a Bloom filter on top of those data. The Bloom filter said that the data definitely does not exist, or it might exist. When it might exist, then we go and do a brute force search on the entire data set. Otherwise, we just skip that chunk and go to the other chunk. We use also Huffman encoding to do a compression. So the fitness trackers data are in tabular format. So lots of repetitive data, and with Huffman encoding, we are fairly successful in making a significant compression. Then for the query executions, we use the work that I'm going to explain it later. But so this is the structure of the data that we store. We're using a JSON format to store the data. One of the context sensings that we did for the smartwatch, and the other one we used for the smartphones. We combine them together and use the same format to store the data in JSON format because the data is heterogeneous. As I said, we compress the data with Huffman encodings, and with Bloom filter, we facilitate the search. Again, I have the assumptions that just to memorize them easily or understand them easily, it's just like the novelty is based on combining these two things. Then we use query translators that the user interfaces make a natural language queries from a limited number of questions that a user can ask. I'm very happy that Bradley had these presentations because I realized, except myself, one other person in this planet read that paper. That's we use that data set, the same data sets to construct the questions. And yeah, it goes through the data, through the stored data, and we translate back by doing a Huffman decoding, translating back, and using the same data sets to decode that into a natural language answer. So the data that we stored within the Bloom filter is in a 2 format. Everything is associated with a date. So I would say it's a temporal data. We have a sensor name and a sensor data. So like a heart rate, like a fitness or physical activities. And then I don't like to go into the details, but as I said, Bloom filter is used to search large collections of data and said whether something existed, maybe it exists, or definitely does not exist. And we create a Bloom filters on top of the data. It is a bit array with the hash functions that you can search. Then we have this kind of nested dictionaries. We consider the data is collected by the sensors as a table. We have a table inside the table. One table has a data and the other one has a dictionary. A dictionary has a list of sensors and the binary code. Binary code is the data that is compressed with Huffman encoding. And yeah, when the queries come, we extract 3 things from the query: keywords, date, and the sensors. And we pass it through this kind of processing, and the query results get back to the users. Yeah, this is how we understand to parse the natural language query. So we did all of these things before the LLM and ChatGPT era. So I think we published this paper in UbiComp. This particular paper is November 2022. So we didn't use any large language models, but I'm very happy if you ask me why, then we can talk about that. So we have the question words, the temporal notations like today, yesterday, last week, last year's, etc. The subject to search, and yeah, I skipped these parts. Maybe I'm running out of time. So, but here is the type of the queries based on our data sets that the users can process. These are the type of the query aggregations or aggregated words that we can answer based on the query. One interesting experiments that we have done is that we do experiments with lots of different compression algorithms, and I think this is the most attractive part of this work, is to see in terms of the compression capabilities and encoding and decoding execution times, which one is the most efficient ones, and that is the reason that we decide for the Huffman encoding. So I show a skip comparison with the state of the art, and I show it like this realm is the MongoDB for the mobile, SQLite, brute force, Lucene, and H2. H2 is another source of the relational database managements that can be implemented on the phone. And you can see by using our approaches, we are like getting a query answer in a fairly fast time. And here, sorry, on the smartwatch, let me skip this go to the smartwatch.
How many times did I run this year?
So you see that like 70 to 80% we are faster than the average state-of-the-art approaches that using for the wearable devices to retrieve informations. In terms of the energy utilizations based on the 5 different queries, you see that this small blue dotted line is our approaches for both smartphones and smartwatches. And for the memory utilizations, we are not the best one. Realm is better than our approach, the MongoDB one, because we have an overhead on the pre-processing the data, use a Bloom filter, convert it to the HOF, do the compression, but still better than the others. And for the scalabilities, you see that I told you that the other existing fitness trackers cannot store the data for long term. So we have go until the 48 megabytes on the smartphones and 36 megabytes on the smartwatch. 30 megabytes on the smartwatch. We are able to capture close to the 3 years of the data with ODSearch, and these errors are the typical out-of-memory errors. Thank you.
Here is a great talk. This is Vedant from Northeastern. So I really like the idea that you can sort of scale it down. It's faster, but the kind of queries we're mostly looking at here is you're really just searching, right, of what something's happened in the history. But you mentioned that how LLMs have now come in, and I'm wondering if tomorrow we were to say have more interpretive queries, right, about was there a particular period where I was not sleeping well, right, which is a more ambiguous query. Would that sort of thing be would you be able to reduce that down here, or would we still need to connect to the cloud for that?
At that, we are able to capture some sorts of and or XOR queries, but not in the details that you said. It is a very interesting thing, and what we are exploring right now is to see whether we can incorporate the LLM to do that. The problem with LLMs is that all other neural networks are not good to work with tabular data. So if you work with neural networks, usually you end up using XGBoost, CatBoost, Lite, TPM for working with tabular. But we are working on that and we are extending that. So I can show you some demo of